If you want to know some industries in tech that you could work in, here are 10 exciting industries in tech. My name is Ryan Sam. I'm a self-taught developer. Quick disclaimer, I'm not an expert in any of these fields of expertise, so some of the information might be incorrect. This video's purpose is to show you some cool stuff that's going on in the tech industry right now. If you find one interesting, I recommend you spark some fun by learning more about these topics. Leave a comment down below if you want to know about some of my sources for these things. Alright, so the first thing on my list is embedded systems. If you've never seen embedded systems before, quite a common one is the Arduino. The Arduino Uno is probably the most popular one right now. Basically, what an embedded system is, to my understanding, is it's usually a microcontroller that controls some electrical components that are hooked up to this microcontroller. These can be sensors, gauges, LEDs, semiconductors, all kinds of things that you can hook up to a microcontroller. Now, Arduino is really for hobbyists, but how it's done in the industry is they use development boards. I don't have a development board. I have an in-circuit debugger, which is also similar to how they would do it in the industry. And they don't use something like Arduino to program these microcontrollers. They buy the microcontroller, put it into a development board, and then they can upload their code from a computer to their microchip from there. That's usually in the prototyping stage. From there, after they get their design done, they can just re-up that code over and over and over again in mass production, and at that point you have a product. So some cool things that are going on in embedded systems right now is Internet of Things, or IoT. Now, Internet of Things has been around for not too long, but for a while now. Basically, it's the connectivity of small devices. They don't have to be small, but basically it's being able to connect everything to the internet. Now that it's capable to take these small microcontrollers and connect them to the internet, the power of these little computers have greatly increased. I mean, you walk into a modern home today and you can use your phone to talk to your coffee machine, your oven, your washing machine, Alexa, the Apple Home. All of these different things that you can connect to with just your phone, the smart lights, all these smart house kind of things. These are being done through, well, not always, but most of the time they're being done through your Wi-Fi. Somehow they're connected to the internet, and you can connect to these devices over the internet using your phone or a computer, and that's just crazy awesome stuff that we can do today. It's definitely a popular industry that's growing currently. If you really like getting down to the electronics of building like a small system or circuit, and you want to do cool things, embedded systems are a really great way how to do that. The main language for embedded system is usually C, but sometimes it can be C++, and very rarely it will be assembly code. But I mean, the possibilities with embedded systems today are endless, and it's crazy how much power you can just get in those tiny microcontrollers. Definitely a cool thing to check out these days, and I recommend, if you like that stuff, you should. So my second thing on the list is app development. Now, we all have phones these days, and a lot of us have apps. Not all of us do gaming, not all of us use social media, but we usually have a few apps or lots of apps that help us with our daily lives or provide us entertainment. For example, you might be watching this on the YouTube app right now on your phone. I could go on and on about everything that's possible with an app. I put it into kind of three main categories here, which is social media applications. These are pretty cool, When you're bored, you use these all the time to boost your entertainment or to check daily news or see what's going on with your friends around the world or, wherever they are. Lots of people use them for a career, A lot of people are professional YouTubers. They make money doing YouTube. A lot of people are social media influencers, so they have a strong following on something like Instagram or Twitter, and they do brand deals and can make money this way. There's lots of companies like Facebook and Google that work on these applications, or there's smaller companies too, and pretty much any big company that is a service has some kind of app. You can apply to that company and start working on them. So my next thing would be games. When the App Store was first released, everyone was hopping on building games. Games were like the hype of the time for mobile development, and it still very much is so that people are building games. Apple just released their new game store. You can purchase these games and they look actually pretty interesting. If you've ever wanted to make games before but don't really want to get into like the super AAA level games where you're programming for consoles or computers, you can create something that can still be fun but pretty simple on your phone. You don't need to know any of these advanced concepts or languages. It's pretty much you can drag blocks here and there, and you do need to know a little bit of code to sometimes implement some physics. So yeah, games would be another thing that's pretty sweet. My next thing would be utilities. Utilities help us every day. They save our time. There's always going to be time management applications. There's always going to be some way to maybe help you with your banking, to check your finances, all this kind of stuff. You know, keeping track of your diet. Yeah, there's plenty of things that you can do building apps. The main languages that people usually use for building apps is Swift for iOS and Java for Android. And also JavaScript is now kind of raising up in the market, especially like frameworks like React Native. You can use React Native, program a whole application in JavaScript, and then that code will be compiled to the native language that runs on iOS or Android. So some pretty cool stuff that's going on in the app development industry right now. My third thing on the list is systems programming. Systems programming are the people who make the computer software from the ground up. When you have a bunch of electrical components connected together, they're not just going to run right out the bag. They need some kind of software installed on them. Usually these are operating systems. So we have Windows, we have Mac OS, and we have Linux that are three of the most common ones today. System programming requires you to know how to work with a computer on the very low level. You are building things from nothing, from the ground up. When you're making an operating system, not only do you have to write an operating system, you have to write your own compilers to compile modern languages that create executable binaries that work for that operating system. You're gonna have to write your own file system. How do you navigate from one file to one directory? That stuff doesn't just come from nowhere. That has to be programmed. When you're loading programmers, you need loaders and all these kinds of things to make an operating system work. This can get really advanced to what you can get into with system programming. Usually these kind of jobs require people to have like 10 years of experience or even more. The main language for this is, since you're working on the low level, is going to be C, but you are going to be writing a lot of assembly code as well, because I know specifically when you're writing a bootloader, which is what boots and loads an operating system, the CPU can't run C programs right off the bat, so usually they have to run an assembly program, which then runs a C program. Usually you're going to have a team. It's pretty hard to write an operating system. Like, it's pretty hard to write everything in an operating system by yourself, but yeah, it's a really cool thing to do, and it's definitely a career to transfer into if you're interested in that kind of stuff later in your career. So my fourth thing on the list is web development. Now, we all know that the web has websites. These websites have boxes and colors and styles and text. That's not really what I'm going to talk about. That's pretty cool, but that would be more on the topic of user experience or user interface. But what I specifically want to talk about is the technology of the web itself. I think right now we are currently using Web 2.0. Everything is transferred over the HTTP protocol using a TCP or UDP connection. This is how basically everything on the internet talks. So those embedded systems I was talking about earlier, your computer, your printers, all these kind of things that use some kind of protocol that can connect over the internet. What Web 2.0 is basically a standard of how the web is supposed to work. TCP is when something sends a data packet on the receiving end, that packet has to be confirmed that it's been sent, otherwise you get an error. And UDP is if you send a data packet and the receiving end doesn't care if it gets that packet or not. If it doesn't get that packet, I'm not an expert on this, but I think it can either be skipped or it would send a signal that it didn't get the packet. It doesn't really mess anything up. It doesn't really care if it gets the packet or not. And then we have APIs and databases, which usually use the REST API, or Facebook is developing an awesome technology called GraphQL. and these are just ways how to access your database and create queries. The power of a database these days are crazy. People that have open source databases, such as something like Spotify, which I have for one of my websites, I can access all the data of my user information. I can pull my playlist, my songs, my email, all my personal information. I can pull all of that data out as long as you agree to send that information to a website. But APIs and stuff don't only work with websites, they can also work with apps. You can load data into an application through an API, still using the same HTTP protocol. The web, as we all know it, is super powerful. And there's crazy things that you can do with it. It's a really exciting thing that a lot of people are involved in, such as myself, and it's kind of the buzz right now. So it's also a great place to get started in your programming career. Most jobs are some job in web development, and either programming in the front end or the back end. The main languages you'd be using for this are JavaScript and some back end language, whether that be like Python or Golang or Java or C#. Yeah, there's plenty of things that you can do on the web these days that are really cool. So my fifth thing on the list is machine learning. Now, I'm not even going to try to act like I understand this space, but there's definitely some awesome things that's going on in it. It's definitely a very popular and uproaring space in tech right now. They even have boot camps solely focused on learning machine learning. But machine learning is essentially giving a computer some test data, and then that computer then weeds through that data and learns, I guess, what the correct answer of that data would be. For example, a company like Tesla, they use computer vision to allow cars to see, and they use the data that they're getting from that video or images that the car is taking to then make decisions on how to maneuver around traffic or how to autonomously drive. Another thing would be intelligent robots, which I'm going to touch on a little bit later. But we have all these robots now that can learn how to do things by making mistakes and then using that sample data to correct itself and eventually get better and better and better, and eventually it's a professional at what it was trained to do. Like there was a computer, I don't know the name of it, I'll put it in the video, that beat the best player in Go. Go is a really hard game. I think there's like millions of different possibilities and moves that you can do in the game. So for a computer just to come out and be able to make decisions on how to play a really good game of Go is crazy, that you can use a machine learning algorithm to train a computer to do a task like that. Another thing that it's used super huge for is tracking data. For example, YouTube. It knows the kinds of videos you like. It knows when to recommend my videos to you, when it knows when to recommend someone else's video. It knows what you dislike. All these different applications and websites and stuff that say recommended for you, that's usually using some kind of machine learning to figure out, to track your data and see what are the things that you tend to like more. These are usually complex algorithms that take several different data points of what you're doing when you're using their application. Pretty cool stuff that you can do with machine learning these days. The main languages for this would be usually Python, or in some cases C++, but C++ takes a long time to write these algorithms. So nowadays, to speed the process up, they're usually using Python. So my sixth thing on the list is computer architecture. Now imagine designing a CPU from scratch. That's something pretty cool. Imagine if you were on a team that helped build a CPU. That's a pretty cool project to be working on. Now, computer architecture usually consists of creating a CPU, which is a central processing unit, and then the ALU, which is the arithmetic logic unit, which does a lot of math computations on it. You're going to be making your own registers, and you're usually going to have some hot loading RAM on this chip, or you're going to create some kind of interface to connect to RAM somewhere else on the circuit board. When you're building these CPUs, you have to make your own instruction set and write your own documentation. And these instruction sets usually have opcodes, which I think are binary numbers that sit in front of the rest of a binary number that tells you what that specific instruction is going to do when it runs through the CPU. So usually in computer architecture, you're not really necessarily programming. Like I said, I'm not an expert, so I'm thinking you might be using assembly, maybe, but usually you're working actually on the electronic level and you're working with gates to decode binary numbers. And that's how eventually these things get built up and become a CPU. But I mean, it's some really cool stuff, especially if you like that real low level hardware. I kind of like learning about that stuff, so it's a pretty sweet thing that's getting better and better every single year. So my 7th thing on the list is quantum computing. Another thing that I'm not an expert, quantum computing is really complex and there's a lot of things to know about it. But the 2 things that I have kind of seen a little bit of information on is quantum computers have these things called qubits, and these qubits can be in certain states. I'm sorry if I'm not saying this correctly, but one of these qubits has the ability to be in the state of superposition. It can either be 1 or 0 or in between the 2 of them, or 1 and 0 at the same time. Not really sure what that can do, but it can really do some crazy stuff. I know they're using it to mimic things in chemistry and biology, but it's really powerful. Another topic that they talk about in quantum computing is entanglement, which from my understanding is when one qubit basically mimics another qubit. Say one qubit is some state, well, another qubit would be basically mimicking that qubit. Another thing that I don't really know what it does, but like I said, eventually quantum computing is going to be super powerful. But I mean, it's definitely something to get into, especially for you physics nerds out there. There's a lot of physics involved. I think this stuff is awesome, and I'm super excited that we're able to start building quantum computers these days. The languages that you would be using for quantum computers, they don't really have languages yet. It's not like modern computers where we have all our languages for them right now. Currently, they have some early stages of assemblers, so you can write some assembly code, but for the most part, that's about as high level you can get when it comes to a programming language. You can actually program on these computers today. I know IBM and I think Microsoft has these quantum computers where you can basically go on a website, you can write some code to run on a quantum computer, and then you send that code. Usually multiple people are using these quantum computers at once, so you have to wait for your program to run, and then you'll get your result back, and that's kind of a way how you can start playing around with these things today. I'll make sure to put some links in the description or on the screen. My 8th thing on the list is game programming. Game programming is awesome. There's so many things to learn about game programming in terms of just making a really good story in a game, or calculating the physics of wind and the sun and clouds and how all these things work, how objects move, how they fall, all these kinds of things that you can do in game programming. There's 3D game programming, which means the camera can see in 3D space, which can get some really complex graphic programming. And then there's 2D programming, which means the camera can see in only 2D space. So usually these are screens that move left and right and up and down, depending on the game. You don't have to be super knowledgeable in math to do this stuff. There's some good game libraries that can get you started pretty quickly on doing these kinds of things. But for those of you who do really like using your math knowledge, you can definitely get super complex in the physics that you implement in your game. And it's just some crazy stuff that you can do right now with games, and it's really fun. If it's kind of your dream to be a game programmer, I do have to say, I've definitely heard from time to time that game programmers don't necessarily get treated as well, and their salaries aren't usually as high as other jobs in tech. That doesn't mean that that's the case for every single company. All companies are going to vary. Sorry about that, my camera died while I was at the park. Also, I'm sorry this video is going to be posted a little bit later today or maybe tomorrow on Saturday, because on October 9th, last Wednesday, was my 21st birthday. And then yesterday, Thursday, let's just say I wasn't feeling the best. But Wednesday was a good night. So my 9th thing on the list is robots. Of course you have the robots that work in factories and do a lot of stuff like that, but right now I'm going to be talking about more complex robots that they're building these days. For example, the company Boston Dynamics is making 2 very popular robots that are kind of getting a buzz right now, which is the Spot robot and Atlas. Spot is the robot I'm sure you've probably seen in the news or somewhere on Twitter. It's a basically a dog with like a long neck, which really is some kind of arm that can be used to open doors, pick things up, and just go in places where it would be a lot safer to send a robot to do that you wouldn't necessarily want to put a human in that situation. It's some very cool stuff. It's crazy how they can get this robot to balance and all the maneuverability that this robot is able to do. It's pretty sweet. Even cooler is their Atlas robot. This is more of like a humanoid robot, I think is what you would call it. But it can do backflips, it can walk upstairs, and there's even this video of it of doing like kung fu, which is probably the coolest thing I've ever seen a robot do. This is kind of a new field where we're finally able to build such complex robots like these. You can get even further on more of the intelligent side of it for a company like Hanson Robotics. You've probably seen the Sophia robot. So Sophia is basically this robot that they designed her face to have all these different kinds of muscle movements. It's really supposed to mimic the reactions and kind of some of the personality and emotions that a real human has. Along with that, it's able to access information off the web, and it can build up its intelligence by finding things online. It doesn't learn everything from the internet. It also has some hard-coded stuff, of course, to get it, started. Most of the examples I've seen, Sophia is super intelligent, apparently intelligent enough that they accepted her as a citizen in a country, I don't know the name, but I'll put it there. Her capabilities of how she can communicate with humans and her ability to learn things on her own is just so cool that we're able to do something like this today. In most cases, the purpose of these robots are to be allies to humans and to help us just do things that we wouldn't usually be able to do. Now, the main programming language for these robots, I'm not actually sure what they're using. They're using a lot of AI technologies, probably a lot of machine learning. I would probably guess that it would be C++ or some C. I'm sure there's got to be a little bit of some systems programming. It would definitely be possible to go to a higher level language and do things that way as well. But I would put my bet that it's mostly C and C++ code. So my last thing on the list, number 10, would be aerospace. Aerospace is a huge field that a lot of people are talking about right now because we have a little bit of a new space race of who's going to be flying missions in space the most and going to the moon and going to Mars and all these places. I do have to say, I do believe that a lot of that was sparked from SpaceX. SpaceX is an awesome company. They're making some crazy rockets that are saving a bunch of money. They're reusable. Elon Musk is a pretty smart guy, so pretty much any company that is running, he does something that's really cool with it. There's all kind of jobs in aerospace that they need people for. But in terms of programming, they're going to need people to write code for things like active stability. How do you launch a rocket from the ground and make sure it stays straight as it's going up in the air? It doesn't just do this on its own. It actually has little motors that pivot the engine at the bottom ever so slightly to keep I think it's the pitch of the rocket directly straight or on path. Any of your flight controls or flight systems, you're going to need some kind of program that's running those things. That's doing sensors and making sure everything's checking out during launch and while it's in space. Kind of a cool fact of computers on spaceships, they actually have to use more than one computer to do something, because when radiation hits a rocket, it could actually flip a bit, and if you have a flipped bit, that can lead to a super bad error. It can cause catastrophic disasters when launching rockets. So they actually use multiple computers. I've usually heard they use 3, and basically one computer checks the other computer and makes sure that the bits are the same. If it's not the same, it'll dump what's loaded and reload some part of the memory, and then do a check again and make sure that all 3 computers are in sync. I'm pretty sure SpaceX isn't allowed to talk about the CPUs that they use in their computers, but I think they're doing it with like a normal CPU that you can just buy yourself. It's nothing special. What's special is whoever the computer architect was that put the system together. Really cool stuff, super exciting. That's actually where I kind of see myself going in the future, is probably doing a lot of aerospace stuff. I'm definitely super interested in that field of technology. That's going to be it for today, guys. I'm sorry for the late upload. Remember, if you like this video, give it a thumbs up. This channel is going to be related around business, tech, and creating a startup company. If you'd be interested in that, please subscribe. My name is Ryan Sam. Thank you guys for tuning in today, and I'll catch you in the next one.